cop. And I'm getting pulled over.
Uh-oh.
The beautiful thing, looking at this police officer behind me, is that I'm driving the speed limit.
That's a good idea. Uh-oh. There he goes.
Yes. Hello.
So this is a wonderful channel. His name is Jason. The channel's called Engineering Explained, and he is an engineer. He has his own channel, and he works on cars. He tests cars. He runs numbers. He explains physics, and so this is him doing some runs on the city streets in his yellow Mazda. It's a Mazda Miata. He put a supercharger in it. That's neither here nor there. I will say that I don't agree with his choices right now. I don't think it's a good idea to be exceeding the speed limit on the city roads, because this is what happens, is that you ultimately will get in trouble. Some of you know this. I know this. I have been in trouble. It's not fun. You shouldn't do it. If you're going to drive in a certain way, you really need to take it to the track, and that is my soapbox. But the reason I started with this is because I am interested in talking about this topic of speed versus velocity. I'm going to do this real quick, and then I'm going to send it over to Mr. Mitchell to do some practice problems. But here's just to kind of get us going. Speed and velocity. Yes, this is me right here. There's my car. Yeah, I like cars, and I've been on track, and everyone needs to go on track. It's a lot of fun. So anyway, speed and velocity. So what's speed? Not the drug. All right. What's speed? Can you explain speed? A lot of my students can't. Everyone understands what it is, I think, in a certain way, in a conceptual way, but they have a hard time explaining it, which begs the question, do they really understand what it is? What is speed really? Can you explain it? Conversely, what's velocity? Right? All right, so what is speed? Speed is the distance traveled and the time it takes to do that. Okay, that's what speed is. Speed is a rate. A rate is anything that happens divided by time. So speed is a rate. So this is perfect for your list of facts, guys. Put this in your list of facts, the distance traveled over the time. Okay, velocity, people will say, is the same thing, and they're used interchangeably. They're not the same thing. Velocity includes one thing. Now look at the difference here. It says displacement over time. This says distance over time. So what's different? What's different between these two? If you said direction, you win. Okay. Distance has no direction. Distance is something that is directionless. Displacement has a direction attached to it. Okay. So when you're looking at something like this, San Francisco's right here. It's the Bay Area, right? So the speed, if someone is driving and they drove for 1 hour and they drove 80 kilometers, whatever that is, right? I guess that's like miles. So if they drove 80 kilometers in 1 hour, then their average speed is 80 kilometers per hour. Okay. Velocity includes one other thing. It includes a direction, right? So if you're in a plane and you're flying at 300 kilometers per hour, which way are you going here? East? Well, then you would have to put that whole thing in here. See, this 80 per, this number doesn't tell us which way they're going. Are they going, east or west? There's a big difference between going east on I-20 versus west, right? So this is important, an important distinction to make. So in my car, this would be what they call the gauge cluster in my car, right? I have these two gauges. And then the little center screen here. This one right here is called the what? This is called the speedometer. It's a speedometer, but that's a word that we've really taken and we've squunched together. Speedometer is really a speedometer, and it tells us speed. So how fast is this person driving? It looks like 65 miles per hour. Which way are they going? Well, we wouldn't know. If it wasn't for this little compass right here, we wouldn't know. Because speed is a scalar quantity. What that means is it has no direction. Okay. Velocity, on the other hand, is a vector. Velocity is a vector quantity, and it has a direction. Just curiously, you guys know what this gauge right here is called, and what does it measure? Does anyone know? This is called the tachometer, and it measures engine speed. Notice that the two gauges, well, first of all the numbers are different, and they're in different places, right? So your engine speed can be different than your linear speed. That's the thing.
I bet you already got a pretty decent idea what speed means. Looked at these virtual labs. We're just here to refine your ideas a little bit. We want to put a little extra polish on that idea of how fast is the thing moving. So on your AP Physics 1 equation sheet, there's several V's that show up. And you haven't looked at this equation sheet much, but you're going to use it a whole lot this year. And you'll see that it has all these equations.
It looks scary.
But then it also has this list of terms. It's basically a glossary. It tells you what all those letters, all the symbols mean. And if you go down this list, you get down here to V equals speed. Now, V is kind of a weird letter to use for speed, isn't it? So really, V is velocity. So we've got to think about, well, what's the difference between speed and velocity? Now, realistically, those two words get used interchangeably a lot, even kind of like this. Even on the AP sheet, it's saying speed, and sometimes it really means velocity. So what is the difference between those two? In common language, speed is what we looked at with the roller coaster and your thing rolling across the table. Speed is just how fast is it going. Velocity, how fast is it going, and in what direction? So, for example, we could just say something's going 28 meters per second. If we want that to be a velocity, we have to add a direction to it. So the direction could be something like east, north, south, east, west. It could be an angle. It could be as going 45 degrees above horizontal. Or it could simply be positive and negative. If we had a number line, and we had an object that's going this way, we call that positive 28 meters per second. If you had an object going this way, we would call that negative 28 meters per second.
Got a question. Is 28 meters per second fast or slow, guys? What do you think? I think that's pretty quick. Here is a meter stick. A meter stick is a meter, right? It's about 3-ish feet. And so 28 meters per second would be 28 of these lined up. You could move, you could travel that distance, 28 of these every second.
So the positive and negative are a direction. So that's a velocity, because not only are we saying how fast it's going, 28 meters each second, but we're saying, is it going to the left or is it going to the right? So how does direction change things? You leave Arlington, you drive south to Waco.
I do.
Here's Arlington.
I do a lot.
I'm going to drive to Waco. It's 160 kilometers.
It is.
Then I turn around and decide Baylor sucks and I want to come home. I drive another 160 kilometers home. It took me 4 hours.
Yeah, Horned Frogs. Woo!
So I went a total of 320 kilometers in 4 hours. I'm going 80 kilometers per hour. That is a speed. Now, if I want to put this in the velocity, I got to take that direction into account. And so I went south for a while, but then I turned around and came north the same distance. And those kind of sort of cancel each other out. So when we think about velocity, we have to think about displacement. We have to think about that idea of the difference between where you started and where you ended. So if you start and stop in the same place,
We talked about this.
the difference between those two places is 0 meters or 0 kilometers. You started in Arlington. You ended in Arlington. You're 0 kilometers away from where you started. Your average velocity is 0 kilometers for 4 hours, 0 kilometers per hour. Let's look at one more thing, and then I'll have some facts for you to write down on your fact sheet that will help make sense of this. Same scenario, you leave Arlington, drive to Waco, you turn around, drive back to Arlington, it takes you 4 hours. How fast were you driving at the moment when you passed the McDonald's in Hillsboro on the way south?
I know that place.
There's Arlington. There's Waco. Somewhere in between is this nice little city called Hillsboro. I assume probably has a McDonald's in it.
I was setting traffic there.
At that exact moment when you went past the McDonald's, what did your speedometer say? How fast were you going? Now, there's not really any way to know this, is there? So that 80 kilometers per hour average speed does not tell us how fast you were going at any given moment along the way. You probably sped up, you slowed down, you stopped for gas, you stopped to buy food, you saw a cop and you slammed on the brakes. So your speed might be changing all along the way. The 80 kilometers per hour doesn't say you were going 80 the whole time. It says that that's how fast you were going on average. So here are our facts. Average speed is distance traveled divided by how long it took to travel that distance. Back to that example. You drive 160 kilometers south. You turn around and drive 160 kilometers north. Let's just say that took you 4 hours, I think it said. So your total distance traveled is at 320 kilometers. Remember, that's the thing that the odometer on your car is going to show. It took you 4 hours, so that's a speed. So average velocity, this is just putting into fact form what we did in that example, is displacement divided by time. So we're not thinking about the odometer anymore. We're not thinking about just how far you went. We're thinking about how far are you away from where you started. The difference between where you started and where you ended. So if you start and end in the same place, your average velocity is going to be 0. Now this is not on your equation sheet. It looks like an equation. Seems like it should be on there. The reason this isn't on there, as far as I know, is because this is really kind of more like a definition. So when you write down this fact to justify a question for me on assignment, a quiz, a test, you can write it down in words, or you can write it down as an equation. They mean the same thing. So if you understand the definition, the equation follows from the definition. How far are you from where you started? How long did it take you to make that trip? Now finally, a fact that gets at that question about driving past the McDonald's in Hillsboro. It's pretty important to think in here about the difference between average velocity and instant velocity. How fast are you going right now versus how fast are you going on average over some period of time? So instantaneous velocity, how fast are you going right now? The thing about this is we can't calculate this. So anytime you got some equation and you're saying velocity is delta x over t, this is inherently an average. Because it's just looking at how far you went and how long it took you without thinking about any individual moment in time. The only way that you're going to be able to find an instantaneous velocity, how fast am I going right now, is with things like a radar gun or a motion detector, which is basically a little radar gun that we could use in the lab, or the speedometer on your car. So if you're actually driving, you can look down at the little speedometer, thing like that, and you can say, hey, I'm going 90 miles an hour right now. Better slow down. So that tells you how fast I'm going at this exact